And force is what kind of quantity? Is it a scalar or a vector quantity?
Force is a vector quantity.
Force is a vector quantity. It has both the magnitude as well as direction. And magnitude of
Hmm.
force is basically the strength of force. How stronger or weaker the force is acting on an object is called its magnitude, and the direction in which direction it is acting. We consider the direction as well, and therefore we say that force is a vector quantity. So today we'll start a session with the introduction of laws of motion. So there are certain laws of motion. We'll discuss these laws one by one. So before moving forward, let's first consider small concepts that we had discussed in the previous class as well. So to move a football which is at rest, someone has to kick it, right? If we want the football to move, then we need to apply force on it. We need to kick the football to move it. And similarly, to throw a ball upwards, one has to give it an upward push, right?
Hmm.
If you give force in upward direction, only then you can, throw the ball in upward direction. In the same way, a breeze causes the branches of a tree to swing clearly, and so some external energy is needed to provide force to move a body from rest. See, you can see the wind, you can feel it. No? How do you know that there is wind, there is air blowing?
We can feel it.
Yes, we can feel it. You can see the branches, they are moving. It is clear that there is wind, right? So there is some
Hmm.
kind of external energy which is needed to provide force to move the body from rest. Likewise, an external force is needed to retard or stop motion. If I want to stop a moving object, retard means retardation we had done in the previous chapter, right? Retardation is deceleration where the velocity changes, velocity decreases. So if we want to stop a moving body, then we need to apply external force in the opposite direction to stop it or retard it, right? As you can
Hmm.
see, that the man was driving the car and suddenly he hit the ball and accident took place and he just fell. So this is a case where some external kind of we have a wall like something which is stopping the car, or you can apply the brakes to stop the car. No.
Hmm.
So we look at this now. We have a road and there is a car, red color car. It is moving on the road, and so for to stop the car, we need to apply brakes or we need something some obstruction to stop it.
Hmm.
So in these examples, the external agency of force is in contact with the objects, right?
Hmm.
So look at this now. So these are the forces with contact. You can see. What do you see here in the picture?
A boy uh
Is
cutting the
moving the
grass.
lawn like
Yes. So he has a machine,
lawn.
and this machine. Yeah, have you ever seen something like this? A machine like.
Yes,
Yes,
ma'am.
ma'am.
I
We do
uh,
this in like we cut the grass with that. Like it's called lawnmower.
Yes.
yes.
So here the force, these are contact forces where the two objects, they interact with each other and they are in physical contact. So, but what about a magnet? A magnet can attract an iron piece from a distance. So, is this a contact force? Do you see any physical contact between the magnet and the iron
No,
piece?
no.
No, there is
No,
no
ma'am.
physical contact between the iron
It's
piece and the magnet, but
magnet,
still magnet can attract it.
magnetic force.
So these are the forces, the kind of forces which are without contact, non-contact forces we say. And we have
Hmm.
read about contact and non-contact forces in class 8. So there were three types of contact forces that we had discussed and two or three types of non-contact forces that we had discussed, right? So can you give examples of contact forces that you have studied in previous classes?
Contact forces
Where
like
the objects, they are in physical contact with each other to feel the force, the force is experienced only when the objects are in contact with each other. For example, in case of frictional forces, one object has to move over the surface of another object because they are interlockings, right? And
hmm.
because no surface is perfectly smooth, and we assume that because no surface is ideally smooth and the interlockings, they just two surfaces get interlocked. like this.
Like
Irregularities
a
get
magnet.
interlocked. Hmm?
Like a magnet.
See, it's not about magnet. I'm talking about frictional forces now. In contact
Yes.
forces, there are three types of contact forces that you had done in class 8. One such contact force was frictional force that we had done in the previous class. So we say that no surface is perfectly smooth. No surface is ideally smooth. If I say that I have a phone and I have kept something on it, these are the two objects which are in physical contact with each other. But we
Mm.
assume that no surface is perfectly smooth. There are irregularities, right? Which we cannot see even if you're walking on a marble floor is not ideally smooth, so there are irregularities between on the surfaces which we do not see usually, and when two surfaces are brought in contact with each other, the irregularities get interlocked like this. You can see consider these two as the surfaces and the irregularities get interlocked like this. So we need to apply force to break the interlocking so that one object can move over the surface of another object. So this is an example of contact force, no? Where the two objects are in contact with each other, right?
Mm.
And in non-contact force, as you can see in the picture, magnet can attract the iron piece from a distance. Means that there is no physical contact, but still magnet can attract the iron piece, which is kept at a distance. So this is an example of non-contact force. Even gravitational forces are non-contact forces. You can see
Mm.
that Earth revolves around the sun,
When the
moon revolves
heavier
around
object
the Earth,
is
right?
in the middle,
Please come
when
again.
the heavier object is in middle
Hmm.
and lighter objects are surrounding,
Hmm.
uh,
Yes,
uh, like yes.
yes. So there is no physical contact, right? In gravitational
Mm.
forces as well. So in magnetic forces, there is no physical contact. In gravitational forces, there is no physical contact. In electrostatic forces, there is no physical contact. Have you ever tried rubbing the comb with the hair and then attracting the pieces of paper? Have you ever played like this in
Yes.
your
Yes,
break?
Yes,
ma'am.
ma'am.
Okay.
I tried with a
Uh,
a ruler.
with the scale,
Ruler. Yes,
like
it
we
is
rub it on the
ruler.
head,
Sorry.
and there are paper
Like
and paper
if we put
pieces,
the
and we
oil
just
in our
yes,
hair and do like and rub with the ruler so it can attract the paper.
Yes. When we rub even ruler, yes, when you rub ruler with a hair and ruler gets charged and ruler can attract the pieces of paper lying on the desk, right? These kind of activities children do, it's like fun activities
I've done it.
in the recess period or break period, right? Even we used to do.
Yes.
Yeah. So what is a force? Please read this definition.
force is a push or a
Also,
pull or a push that generates or to generate motion in a body at rest, stops or tends to stop a body in motion, or tends to change the shape of the body.
Yes, so force is an external effort because we apply force externally on an object. So it is an external effort in the form of push or pull that produces or tries to produce motion in a body at rest. Number two, stops or tries to stop a moving body. Number three, changes or tries to change the direction of motion of the body. Number four, can change the shape of the object, right? So if you apply force on an object, what kind of force is this? We are just applying force in forward direction to move the box. We are pushing the box, right? When you apply force like this away from you, then it is called pushing. And if you apply force towards you, then it is called
pulling.
pulling, right? What is happening here?
A car is
A car, like
there's an
a
accident.
car moving, like
Car hit the tree.
car hit by a tree.
Hmm. Yes, and in the second case,
Two cars
The
are
two cars hit by each other.
so
each
how will
other.
you relate this picture with a definition?
Like two cars going and they like they hit by each other.
They are colliding with each other. They're moving in a positive direction and colliding with each other, and they're exerting force on each other, and car crash is taking place. And in the first picture, car is striking a tree, it is hitting a tree, and it stops.
Hmm.
So there are two kinds of forces. When we give the definition of force, we say that it is an external effort in the form of push or pull. We say that it is the force is applied externally on an object. There is no internal force, right? Do you have any idea of internal forces? Means external forces, I know that suppose I am pushing something or I'm pulling something that is external to my body, right? But what
Hmm.
about internal forces? Any idea?
Like
What
When
are
we do
internal forces?
when brake car brakes,
Come
like
again.
car brakes when we
See, if I
uh,
say that there is a gas cylinder, and in the cylinder we have gas molecules, and because we know that we have read in the chapter matter in our surroundings as well that particles move, move randomly in different directions, and gaseous particles have very high kinetic energy and they can collide, they can move randomly in different directions. So that energy, that kind of force is associated within the system, that belongs to the system, right? But
yes,
something which we are applying externally on the object is external to the system. So if the force applying agent is inside a system, then it is known as internal force. It doesn't provide motion to the system. Object does not move because of the internal forces. For example, if you are sitting in a car and you push it, it doesn't move because you belong to the system. Right, system is what is the system here? You sitting in the car, right? So car is a system and you belong to that system. So if you try to push the car while sitting in the car, you can't move it. No.
hmm,
Similarly,
no.
if you come out of the car and apply the same force, then
we can move it.
we can move it, because then you become someone who
Obey,
does not belong to the
obeying the
system,
external
car
forces.
system. No.
Yes.
Yes. So if there is something which is internal to the system, then it does not affect the motion of the system. So one has to apply force externally on the system to make it move or to change the state of motion. Clear?
Hmm.
So internal push doesn't move the car. External push moves the car. So it's about the external effort. It's about the external forces that we apply on the system so that the state of motion can be changed. Internal forces play no role there. Clear?
Yes.
Yes, ma'am.
So we have a question here. What is a force? We have four options. Give me the correct answer. It is a pull or a push which tends to move a body, stops or tends to stop a body in motion, tends to change the shape of
First,
the body, all of the above.
All of the
first
above.
A part, I
Yeah.
think.
Read all the parts first. See,
Oh yeah.
All of the
which
above, ma'am.
all of the above is the correct answer. Pritish, why did you say first? What about second and third? Is there anything wrong with them?
Mm,
Have you read these parts?
yes,
Then why did you say first?
because I think like the push or pull,
Yeah,
if in
push
a
or
chapter.
pull tends to move a body. Stops or tends to stop a body in motion. If an object is moving already, then you can stop the body, no? By applying force on it. And we can also change the shape of the body by applying force on it, no?
Yes.
Hmm.
Correct answer is all of the above. This was a definition
We
that
have
we
to
read.
rejoin.
We need to rejoin now.
Yeah.
After 5 minutes.
Okay. Next, what is an internal force? We have these four options.
Both A and C.
See, internal force is something which belongs to the system, which is not the
Oh,
external.
internal force. Oh, it's B.
Yeah, it is B. Force applying agent is inside a system is internal force, right? It is inside the system.
Hmm.
It doesn't provide motion. So next topic is Aristotle's fallacy. But before moving forward, I want you to rejoin because it will take time.
Hmm?
What did he say?
Like
Said that
it's
external force is required to keep the body in motion. External force is needed to keep the body in motion. If we want the body to move continuously, then external force is needed. So what is wrong with this statement? Is this statement complete in itself? Why do we need external force to keep the body in motion? Is there any other kind of other, are there any other kind of forces which are resisting the motion, or there are some dissipative forces or resistive forces acting on the body so that the body stops after moving some time? Why does body stop after moving? Why does body stop after some time?
mm, like by itself.
By itself. So there must be something which is resisting the motion. See, though what he said was right, that external force is required to keep the body in motion, but there was something which is not here. You can see that which is not there in the sentence. External force is required to keep the body in motion. That's correct. But why do we need that external force to keep the body in motion? Because there are certain kind of resistive forces like frictional forces which are always present in the natural world, right? You cannot deny there. If there exists no friction, there would be no need of external force. Though what he has said was right, but this statement was somewhere incomplete because he had not mentioned anything about the frictional forces and external forces. That why do we need external force to keep the body in motion, right? Right?
Yes.
We need external forces because there are frictional forces present in the natural world. And because of those frictional forces, when a body, when a ball rolls on the floor, it stops after some time because in the between the ball and the floor, there are irregularities present and which makes the ball stop after moving some time, right? So he did not mention anything about the resistive or dissipative forces. He failed to realize that external force is required only to counter the frictional forces exactly. So that the two forces, applied force, the external force and the frictional force sum to a zero to get net external force.
Mm.
ठीक है? तो Aristotle fallacy क्या थी? Aristotle said that external force is required to keep the body in motion, but he had not mentioned anything about the need of external force. He had not mentioned that why do we need external force to keep the body in motion? Because there are frictional forces present in the atmosphere. In the natural world, we have frictional forces present, dissipative or resistive forces present, air resistance and other kind of forces. And because these forces resist the flow, these forces resist the motion, and therefore we need continuously an external force so that the external force can, counter the frictional force exactly so that the two forces sum up to zero net external force. So if there is no net external force, if there is net force zero, only then the body stays in motion all the time, no?
Yes.
Next is Galileo's remedy. He to demonstrate the need of no external force for uniform motion. Please write this first. Okay, so we were talking about Galileo's remedy. He actually demonstrated the need of no external force for uniform motion. Uniform motion means the object is moving with constant speed or velocity, and there is no external force needed for the object to be in uniform motion. And how did he, prove this? So he had performed two different experiments. So the first experiment is, you can see the inclined plane here. Do you see?
Yes.
This is the inclined plane. And when the ball is released from the top of the inclined plane, look at the cursor movement. When the ball is released from the top of the inclined plane, its velocity increases. There is a change in velocity in the downward slope. When the object moves down on a smooth inclined plane, the object accelerates. Accelerates means its velocity will increase. And can you please explain why does the velocity increase when we move down?
Because it's round and it gives it like
See, when the object is placed at certain height, then what kind of energy it carries? We have read about different kinds of energies, right? So it carries,
kind
no, it's not kinetic, it's potential energy. Potential energy is the energy possessed by an object by virtue of its position or configuration, right? So when the object was stationary and it was placed at the height, it was possessing potential energy. Okay, and when it goes down, the height is decreasing. You can see that it is moving towards the floor. And because height is decreasing, so potential energy will decrease. Potential energy, gravitational potential energy is mgh. Gravitational potential energy will decrease, and it's the energy, which is decreasing, it gets converted into the kinetic energy of the ball, and therefore its velocity increases on moving down the inclined plane. Clear? And the object is moving towards gravity, the direction of
yes,
acceleration due to gravity and the direction of motion is the same, and it accelerates. And when the same ball is thrown on the inclined plane with some velocity, when the object moves up on a smooth inclined plane, its velocity decreases in upward slope. Look at the second figure. Here the object is moving in the upward direction, right? So when it moves in upward direction, it is going against the gravity, no? Against the gravitational force of Earth or against the Earth's gravity. It is going against it. And you can see that slowly or gradually its height is increasing. It is moving up above the Earth's surface, right? It is going up, no?
yes, ma'am.
So its height is increasing, so its potential energy will increase and its kinetic energy will decrease, its velocity will decrease, and the ball finally stops after reaching certain height. It stops there. Okay, but what if the ball is moving on the smooth, horizontal, frictionless surface? See, here we are mentioning that the horizontal plane is frictionless. Horizontal plane is
Frictionless.
frictionless. Frictionless means there are no irregularities present. There is no interlocking. There is nothing like this, which can which the ball has to resist, and the ball has to go through. Right? There is nothing like dissipative forces or resistive forces acting on the ball, which can stop the ball or which can affect the motion of the ball. Right? So object is moving on a frictionless horizontal plane. It neither accelerates nor decelerates, means there is neither increase in velocity nor there is decrease in velocity. It moves with constant velocity because the horizontal plane is frictionless. Clear?
Yes.
In the second experiment, he had taken hemispheres. You can see the hemisphere surfaces, and Galileo took a smooth hemisphere and released a ball on the inner surface. He released the ball from here and he observed that the ball moved to the other side and reached the same height before coming to rest for a moment, and reached the same height before coming to rest for a moment. The ball continued its motion from left to right and then right to left. It moved like this. If the surface is smooth, then it moves like this. But when the surface is tilted, you can see here in this case, and or it is made horizontal, as in the third case, you can see the surface is made horizontal, and you can see that because there is no friction, we are assuming the surface to be frictionless. We are assuming that the surface is purely frictionless, so there are no frictional forces, there are no dissipative or resistive forces acting on the ball. So ball would continue to move with constant velocity on a horizontal plane. It will move constantly, it will move continuously because the surface is frictionless. So what he had done was that he had taken the surfaces which were frictionless. Frictionless ideally do not exist, but we are assuming that the surfaces were frictionless. And on the frictionless surfaces, there was no change in velocity, no change in speed, and the object continually move if it is placed in the horizontal plane. But if it is placed in, inclined plane or something like that, so if in that case, there is gravitational force acting on the ball, and because of the gravitational forces, velocity is decreasing. So what do we understand from here, that if there are certain kind of external forces exerted on the object, only then there is change in velocity. Like in the first experiment, there was gravity, right, which is responsible for it, so gravity was
Yes.
responsible in the first case. In the first case, ball was moving downwards, so it was moving towards gravity, while in the second case, ball was moving upwards, so it was moving against gravity, right? So in both the cases, because there was gravitational force, so there was change in velocity. While in the third case, because there was no gravitational forces, we can say there are still gravitational forces, but it is acting, constantly acting at the same position. No, it is on the horizontal plane, so we have the same type of force everywhere. So there was no change in velocity. Okay,
Okay. Yes.
can you explain this to me?
Yes.